All right. Welcome, everybody. My name is Sonja Brodt, and I'm with the UC Sustainable Agriculture Research and Education Program. We're one of the statewide programs under UC Agriculture and Natural Resources. And I'm going to start with a few housekeeping things here and a very quick introduction to the broader initiative that this is all part of today. Let's see. Try that. Okay, so as Chris already mentioned, we are recording this today. And if you are concerned about privacy, you can turn off your video while still listening to the speakers. We would like, if possible, if you can put questions into the Q&A at the bottom of the Zoom bar, and maybe keep the chat more for comments and discussion, but we'll be monitoring both anyway for questions and input for the panelists. And we'll hope to have some time after each section of the presentation today to address some questions. Finally, there's a new policy about AI-powered services. So because we strive to host inclusive, accessible events that enable all individuals to engage fully, we do allow the use of AI-powered note-taking services and transcription services, such as Otter AI. However, the transcript or notes generated should be retained solely by the individual utilizing that service and must not be further shared. Other AI meeting tools, such as facial expression and engagement analysis, are not permitted. And in accordance with university policy, once the notes have fulfilled their intended purpose for you, we ask that you destroy them to ensure compliance with data privacy guidelines. Okay, and with that, let me start by letting you know a little bit that this event today, this webinar, is part of a broader initiative and an activity called the California Farm Demonstration Network. So this network was established with a memorandum of understanding that was signed between 6 different agencies across the state. So all the big players in ag, outreach, and research. And there's kind of 2 aspects to it. One is that it was the idea to have us all, these large institutions and agencies, coordinate better with one another to amplify efforts and speed up efforts to increase adoption of conservation farming practices. And the other aspect of it is to actually do on-the-ground farm demonstrations by enlisting demonstration farms and using them to host farmer-to-farmer learning events and to build up participatory learning networks. And again, with the goal of ultimately increasing adoption of conservation farming practices like soil health practices, water saving practices, and other kinds of climate smart practices. And so currently, this effort is funded by a University of California Climate Action Research Grant. And this is just a quick overview of the structure of the network. We have 5 different hubs around the state. The hubs are generally managed by resource conservation districts in conjunction with cooperative extension advisors. And we also have a Hansen Research and Extension Center involved. And they do the on-the-ground work with the demonstration farms and putting on applied research and outreach events on conservation practices. And then organizations at the statewide level, like my organization, UC SAREP, we provide capacity building activities such as this webinar today, and we facilitate knowledge sharing and communications across the network. So if you're interested in learning more about this, we're definitely, happy to reach out and get more people engaged in this, especially within A&R and other resource conservation districts and other organizations in the state. You can see the website. There's already a lot of demonstration farms on the website. That's calfarmdemo.org. And if you know farms that might want to be on there, you could reach out and they could add themselves or we could add them. And you can also reach out to the CFDN email or directly to me at my email if you'd like more information on how to get involved in this California Farm Demonstration Network. So with that, let me say that today I'm very pleased to welcome Chris Greer, who is the area cooperative, or I'm sorry, I'm pleased to welcome Sean Hogan, who's the A&R Informatics and GIS statewide program drones expert. And he has been with the program since 2014 and leads drone services for the program and for UC A&R as a whole. And he will be leading the webinar today. And he will be joined by Chris Greer, who is Area Cooperative Extension Advisor in Integrated Pest Management, serving San Luis Obispo, Santa Barbara, and Ventura counties. And finally, I'm happy to welcome Ahmed Kayad, a Cooperative Extension Agricultural Engineer Advisor, and he's based at the UC Intermountain Research and Extension Center in Tule Lake, California. And he serves Siskiyou, Modoc, Lassen, East Shasta, Plumas, and Sierra counties. So welcome. They have extensive experience in the field use of drones for research and extension. And with that, I will turn it over to you, Sean, and I will stop sharing.
Great, thank you. Great introduction. And I will switch to my share. Does that look good for everyone?
Yep.
Great. Okay, so yes, we're going to be talking about Drones 101 today, specifically using drones to enhance agricultural extension and research. Just a little note, there was mentioned that you could put your questions in the Q&A. We've found over time, often because I'll just be presenting and it'll be hard to follow both the Q&A and the chat at the same time. If you'd like to put your questions in the chat, that would be great. And then we have a number of people that can field those questions, but at the end of each of 3 presentation/roundtable discussions, we will have questions and answers that we can go back and forth on for roughly 5 to 10 minutes after each section of us presenting something. Speaking of those somethings, those will be the applications of drones for agriculture and natural resources, essentially to whet your appetite for different things that we are doing out there. We'll cover technology and data products a little bit, more technology, less on the data products, but the tech side of things. And then finally, we'll discuss integrating drones into research and education programs. But here's something that I want to kind of, is an overarching concept that we'll try to embed into this, is the things that we wish that we knew when we first started. Chris and I were a part of a discussion yesterday, that's Chris Greer and I, about over and under expectations of what you can do with drones. Sometimes you expect you can do more, and sometimes it exceeds your expectations. So we'll try to touch on that where we can, and that applies to all of these areas here. So just kick it off. We'll talk a little bit about agricultural applications, and for this, I'll give some slides, and then I'll let Chris and Ahmed contribute with their some slides there. So thinking of value of drone applications, one of which is detailed project mapping. One of the main areas of drones that, of course, compared to something like an occupied aircraft or a satellite image, is that you get incredible high resolution imagery, and when you need it, oftentimes. I mean, granted, you have to work around weather and things like that, but you have the opportunity to get on demand, extremely, or you might say hyper high resolution imagery in your areas. And this is great for project mapping. And with that, you can coincide your image collections with field data. And this is just one example from the Lynn Cove Research and Extension Center, where we worked at pairing imagery from an orchard to a citrus orchard with pack line data. This was just an experimental trial some time ago, but this is one example. It could be anything, though. A lot of these things that we'll be covering are the same techniques can be conferred to another type of project. I've done another project once upon a time of looking at fecal coliform surrounding cow patties in a field, where we identified the cow patties, and then the samples were then reattached to those uh, the chemical analysis and the biological analysis were then reconnected to the imagery for spatial analysis. So those are examples of how you can combine field data. That's a valuable way that you can use drone data. You can just use it for basic crop assessment. This would be an example of almost my first project, or close to being one of my first projects, of looking at different fields, in specifically how it relates to irrigation. Jairo Diaz might recognize this from many years ago down there at the Desert Research and Extension Center. And it was neat to see that even using a simple RGB camera, which might be all that you can afford in some cases, we'll get onto that, you can see trends in irrigation. For example, you can see in this imagery where there's light and dark images along some of the fields, kind of in a washboard effect, that are partially might be attributed to emitters, like releasing more water in one area than another, be an example. I'd be remiss if I didn't touch on one of the most powerful things about drone imagery as opposed to normal occupied aircraft or satellite imagery, is that you can use photogrammetry. And what this process is taking multiple pictures and combining them using stereo photogrammetry, essentially nowadays digital trigonometry, to get not just an XY position, but a Z position, Z being elevation, of sometimes millions of points within your imagery. And then you can get points for all the features within your area of interest. And with that, you not only do you get spectral characteristics of your target area, but you also get elevational values, which are great for structural analysis. And with that kind of plant, or in this case, tree structures we're looking at on the left side, you can do plot analysis. So you can analyze each tree, both structurally, size, referring to height, shape, crown width, that sort of thing. And then you can do zonal statistics for each of those plots to get more detailed information out of that. You can tease out all kinds of different scientific questions there and answers. An example of that we've used in the Russell Ranch experimental plots just west of Davis, west of the university, is looking at genomic differences or the differences in structure between different genotypes of pistachio orchards. It's a fairly robust project that we spent quite a bit of time working on. And with that, you can see on the right side, you can see all these delineated orchard trees, and then see kind of over time, this was actually a time-lapse project of different sizes and shapes of those trees throughout time. And then that could be rematched to field data. Along with that, we were able to get NDVI, which is Normalized Difference Vegetation Index, is a proxy measurement of vigor and health of the plants. It's just an extra additive, and we'll come back to that when I talk a little bit more about data products. One neat thing that came out of this project, I don't know if that we got so much about the characteristics of the genotypes of the trees, but what we did find was that in about 3 to 3.5 days, we could fly the drone, we could process the data, we could analyze the data, and then visualize it. And that 3 to 4 days of work would take about a month or so to do in the field with someone going out and measuring it from the ground. So there is a very practical applications for research when it comes to that sort of thing. Through in this slide, also did another project. This was published some years ago about water efficiency at the Kearney Agriculture and Research Extension Center, using similar segmented zonal statistics for different treatments. In this case, burn versus grind and irrigation, full and deficit irrigations. And this was related to thermal imagery. And I throw this in there with intention to point out that things don't always work out with drone imagery. Particularly thermal imagery is tricky. You have to have pretty significant differences in thermal imagery to really detect the changes that you might be interested in. And it's very contingent on the day, the effects of the day, the water, stress or non-stress. There's a number of things that play into that. So there's, with the little caveat, thermal imaging can be very challenging if that's something of one of your interest areas. An example of thermal imagery, though, that might be very useful is when you have more dramatic differences between one area and another. And this is a evapotranspiration and surface renewal project that we've been working on with Daniele Zachariah. To the left, you see just a regular RGB or red, green, blue image up near woodland. And each of these two, if you can see that on your screen, there's a red kind of delineated circle around a red dot, that red dot being a weather tower, and then an orange one. And each of those fields have different treatments or irrigation treatments. So you can see the drastic difference in color. And that drastic difference in color also is reflected in the thermal characteristics to some degree, would be the center image that we're looking at there. And then far to the right, one of the things a lot of people often try to do is it's been in remote sensing circles, kind of a holy grail of for applications, is being able to scale up. And so those blocks around the towers that you see on the far right image are Landsat footprints that surround that area, where we could compare Landsat thermal imagery or specular imagery with the values coming from the towers to see if there's differences. And that stuff can all be related to most of like water use efficiency and yield. And with that, I'll turn it over to Chris, I believe. This is your slides, I believe.
Yeah, I guess I put my slides on the wrong spot, so thanks for moving them.
All right, no worries.
So I just wanted to talk a little bit about, I mean, I found when I talk to growers about things, there's you know, a difference between using imagery for research versus using imagery in actual production or for some useful reason. So, you know, for research, we're looking, because I'm taking multiple images throughout a season, we're usually looking for that, you know, 1 centimeter uh, resolution and trying to get everything lined up exactly the same. Whereas for a production purpose, if you're looking at 200 acres, it may not be that big a deal. So sometimes we have to think of it a little bit differently, what we're doing with research versus what may be useful to a grower. But this is just an example of one of the things I'll use. Multispectral imaging, and so this is a NDVI orthomosaic. This is a project with another advisor where there were multiple plots. This is strawberry, so these are each about 20-foot long sections of beds. So I can segment each of those. They have different treatments, whether it's irrigation or nutrient applications, and we can basically get a NDVI value from each rep of each treatment, and so it gives us a number to work from, in addition to just having yield data out of those plots, versus a visual rating or whatever someone else may do to calculate differences in the treatments. You go to the and then the other thing, go back, I'll mention one more thing. The other thing I find really valuable, especially where, you know, you may have multiple crops in a season, or growing the same crop from season to season, is that temporal value of the data So in a season, I can have imagery from every 10 days throughout the season, so we can follow along how things change. But also, I can go back into previous years and see where we had issues, whether it's a pest issue, nutrient issue, irrigation issue. So go ahead, Sean. And then my last example, this is a couple of slides, but this is one, again, strawberries. We had 4 different blocks. Each of these blocks is about 2 acres. So we split them in half. This is NDVI imagery at the end of the season in 2002. So each of these blocks we split in half, and then we designated one half of the block was going to be our normal grower treatment, which is the highest rate of fumigant for soil-borne pathogens. And then the other block, we tried to talk the grower into doing some variable rates, reducing fumigant rates in areas where we were not seeing very high rates of disease. And most growers are very hesitant to do that. They don't want to go below the highest rate. And so go on, Sean, to the next one. And then so you can see here, they wanted to start out sort of slow. So we had some small areas that we were able to back off on the fumigant rate. Block number 4, you'll notice is very red, which means almost every plant in that block at the end of 2022 was pretty much dead. So we agreed with them, okay, we're not going to use a low rate of fumigant here. But so you can see in the other 3, block 1, 2, and 3, we have variable rates, and we had some areas with a low rate of fumigant, and some areas we had a medium rate. Next one, Sean. And then what we saw at the end of the following season was, even in these areas where we had the lower rates of fumigants, we did not see any difference as, compared to where we had the higher rates. Remember, we were using the imagery to pick out areas where we didn't have as much disease incident. So, we would link that with also, we wouldn't have as much inoculum for the following season. So then we took this to a second year. Go to the next one. And this will be the last one. The second year, the grower was a little more comfortable after the first year. So you see in block 1, our variable rate treatment, we basically did that whole acre was either the low or the medium rate. And we did half of block number 2 with a low rate. And then over in block number 3, we did the entire thing with a low rate. And I don't have the image. I don't have the image, but I'll tell you what we found when we reduced these here is, we didn't see any significant increase in disease incidents where we're using a low rate. And then we also collected yield, which is a lot of work in strawberries, because if you think about it, they're harvesting every 3 days. So it's not like you just go out at the end of the year and harvest. But they collected yield data at every harvest period. And we did not see any difference in the variable rate versus the full rate. So this one have been pretty good for looking at things over, multiple years and across the entire season as well. So this is one of the things we're thinking about from an application standpoint is where you could get to using it in a real application. Okay.
Awesome. Ahmed,
Yeah, I will share my screen.
I'll stop sharing here.
Okay.
And you're free to share yours.
Okay, can you see my screen now?
Let's see.
Yep.
Yep.
Okay. So I'm Ahmed, and I work at the Intermountain Research and Extension Center. In our research center, I have also some applications here. for drones. So in our research center, breeders test different varieties of potato. And for the last 2 years, I started using drone images weekly, collecting weekly drone images from these variety trials. And our goal is to have a digital archive for the development of these different potato varieties, and also to start a kind of digital scoring for the performance of these varieties. So, for example, if you look to this left part of my slide, you can see one of the drone images, and we have a box 5 feet by 15 feet, and we put this box in the center of each variety. So we can calculate from this box the NDVI, for example, and then we did a classification so we can detect the area of vegetation, only the area of vegetation. And this helped us to see which variety can reach the row closure earlier. So this was one of the applications. And the other one was to have, as I said, the archived images. So at the end of the season, one of our colleagues, he's an expert in giving the scores for each variety for a disease detection and disease score. So at the end of the season, he compared what he collected during the season with these archived images, and we got actually a very good correlation between this between what he did on computer from this digital archive and what he did in field. Another application here, near woodland, there are many tomato fields, and there are new transplanters. So the conventional transplanters require many people working behind the machine, and there are new automatic tomato transplanters. The growers was looking to test these new transplanters, and we tested we tested 4 different transplanters in 3 growers' fields. In each field, we had 3 replicates, and we had to count a huge number of tomato stand. So we used drones to count this tomato stand from these study fields, and we counted over 300,000 tomato plants. And we succeeded to do this, and we could also have a digital archive for this experiment, so researchers or growers can go and check the gaps, as you can see here in this right part of this slide. Another application is a spatiotemporal analysis technique for weed detection. So this was exclusively for transplanted crops. You know, at the beginning of the season, before planting, after we planted, here it was a pepper example. After we planted this pepper, we flew the drone, and we could detect the position for each plant. And after 3 weeks, these plants grow and weeds grow as well. So we flew the drone again, and we could detect, and we could have an NDVI map, so we know where is all vegetation. We overlaid this map with the first map with the plant positions, and anything overlaid, we considered it as pepper, except you have a really big polygon. A very big polygon here means a case like this, where you have a weed grow between these plants. So we put a buffer, and anything inside this buffer, we considered it as pepper, and anything outside it, we considered it as weed. This is a spatiotemporal analysis, and when we applied it, it was quite successful in detecting weeds in a study field in pepper with 95% accuracy. And also we tested it this year in a tomato field, 30-acre tomato field, and it was also it gave a really good results up to now, according to our analysis. Here also another application, so weed detection in onion fields. We used multispectral images to compare to classify this field to detect weeds. So here, if you look at this left part, you can see RGB image from this field with onion and weeds. And when we looked at the near infrared image, we found that the onion has low near-infrared reflectance compared to the weeds. And this was a feature in this crop. So we used this feature to discriminate between weeds and crop. And as you can see here, some examples. If you see my slide, okay. So here, if you look at this example, you can see that we could successfully detect all weeds in this slide, in this field, as you can see here, some examples. And as you can see, weeds are patchy in the southern part of the field. So it's a good example for a potential for site-specific weed management in this field.
Is that because of the spectral reflectance difference, or because the weeds are so much larger than the?
It was just because the weeds has different reflectance. So
Okay.
if you look here for this image, this is the near infrared, the one in the middle. And as you can see, this is the onion compared to the weeds. So the values was really significant. There is a significant difference between the near infrared reflectance from onion to the weed. Here is another example for how we use drones for alfalfa yield sampling. So we have here a project, we call it Tule Lake Yield Mapping, and we collect yield data from alfalfa fields. So the common way we go with a frame, we put it in at the top of the alfalfa swaths, we cut all the hay inside it, and then we take the fresh weight, we take a sample for lab analysis, and we calculate the yield from this technique. This, for example, we were 6 people working for 3 hours in just a short area, one span of a center pivot, to collect only 30 samples. So we came up with another idea. What if we fly the drone after baling alfalfa? This is small bales, and after baling, we took this drone image, and as you can see here, the bales. So this bale is formed from the distance between 2 consecutive bales. So from drone images, we could calculate the distance between 2 consecutive bales. And since we know the windrow widths, so we know that this is the area that formed one bale, and this, we can convert this directly to a yield. For example, the distance here between these 2 bales was long. It was 56 feet, and this means 1.45 ton per acre. While here in a shorter distance between these 2 bales, it was 41 feet, and this means 2 ton per acre. This was a quite easy and simple way to do alfalfa yield sampling. We repeated this exercise 100 times over this field. It's 30-acre field again, and in less than half hour, and we could have a really good number of alfalfa yield samples. Finally, this is a new technique also for alfalfa hay volume mapping. So we were thinking, okay, what if we fly the drone after hay rake, after they do the raking for the hay, and we fly it in the oblique mode, so we can create a 3D model for the hay windrow. From this model, we can detect the digital terrain model and digital surface model. If you subtract these 2 models, you can have the hay windrow volume like this. So we divided these hay windrow to 10 feet long strips, calculated the volume for each strip in this, and we converted it to a buoyant format. And as you can see here, this is the hay volume map for this field. We correlated this hay volume map with yield, and it was quite highly correlated. It was 0.71 with more than 2,000 points from this field. So it was quite correlated, confirmed by the growers. This is his yield map, and also matched well with vegetation indices from satellite images. So these are my presentation. Hello?
Sean, you're
I see I was unmuted.
Okay.
I don't often do that. But so let's take 5 minutes of questions. How does that sound? Does anybody have questions? Either that, or we can transition right into the technology, which I have a hunch will maybe elicit more questions. So if you have any questions, you can put them in the chat or you can speak up.
Jackie has a question.
Jackie.
Yeah, thank you. I have a question. We have been flying drones with different deficit irrigation in sorghum, and we wanted to estimate the yields in different sorghum treatments. However, we have been finding challenge with the reflectance that comes from the sorghum grain, because we're trying to look. So I'm wondering, with such, how do you, or who can we work with to see how we can do that calculation by removing the different inflorescences or grains that come, because as you fly, the gray, you stop seeing the greenness, but you're mostly seeing the reflectance from the grains, the sorghum grain.
So I can give some ideas to that. I don't know exactly it might be one of those. There's a lot of factors. One, what kind of drone you're using. It can matter what time of day you're flying. There's Ali Pereza over on the UC Davis campus has an application for optimal flight times for certain types of crops. I know that. There's if this at certain times of the day you'll have better reflectance than other times, and largely that is related, as you know, to the architecture of the plant's leaves. So to get that, sometimes it might be useful to fly when there's no using ground control targets to on both flight times, but fly when the field is fallow and then fly later times. So then your elevation models can be subtracted from each other because you won't be able to get penetration down to the bottom through a sorghum field. But those are a couple ideas. And then you can you can at least get a proxy measurement of sorghum in theory by like average density, but it's not going to be that exact. And what do you Chris and Ahmed might have ideas on that.
Well, and I think was part of your question as the green starts to mature. I mean, it's, you're going from green to drying down, and so it's so you're probably going up and then coming back down as the crop is maturing. I haven't done a lot of Sean's probably done more, and maybe Ahmed's done some, but I haven't. We have some collaborators that are trying to do some yield estimates on strawberry, but they're using a lot more sophisticated sensors that are strapped onto a tractor and stuff. So I haven't tried to do any with my imaging.
About drought prediction, because our main aim is to predict drought tolerant varieties. We grow quite a number of varieties, and yeah, they're using multispectrum DIV cameras also. It's from I have no details. It's from Marseille, a team in Marseille. There's a postdoc from Marseille that was helping us do that work.
Yeah, and even with drought tolerant, I mean, you can the thermal, like Sean said, thermal has its issues, but if a plant is stressed because it doesn't have enough water, then it's shutting down its it's shutting down its stomata, and you'll see that the temperature of those plants is so much higher than one that has a sufficient amount of water also.
Yeah, with the idea that if you fly with something like an Altum, which we'll get to, and you have multispectral and thermal, and if you have two plants that are the same level of green and near infrared, and one's hotter than the other, then you have less evapotranspiration on the hotter plant, then you have you can measure that way.
There's an interference of the grain.
Yeah.
Yeah.
So that might be an approach. Again, flying at different times of day, that might be key. And sometimes the differences are not going to be visible until it's more drastic. you have to have drastic differences.
Okay.
Sean, and
Thank
maybe
you.
this is a good time to mention also your, you guys' office hours.
Oh, that's a good idea. I usually mention that at the end, but now is as good a time as any. If you have really more in-depth questions that maybe you don't even think about today, but it comes up later, IGIS has office hours on Mondays and Tuesday afternoons. And that it depends on, it doesn't have to be just about drones. It could be about GIS. It could be about web mapping, geodatabase management. We have a team of people that have expertise in all the geospatial tech kind of areas, and whoever's free and best suited for the questions, we can get on there and help you out for a half hour. And so that's open to all of you. And and you can find that link on the IGIS webpage. So just search UCNR IGIS and you can find office hours on there.
If I can add, I think part of Jackie's question is not one that's real easy to resolve because, especially in sorghum, I mean, I've done some work in seed alfalfa versus alfalfa, and at vegetative stages. And if you're doing like a crop water stress index approach, the non-stressed baseline actually changes as the crop's morphology changes. So if you have, non-grain sorghum types that you're trying to compare at the exact same time with ones that don't produce any grain, then the difference in what you're going to get in terms of data is partially impacted by a non-transpiring surface in the grain as part of the image. And so it's not going to be just a straight comparison that's going to tell you that one is more stressed than the other because the phenology has changed. So it gets much more complicated when you have a lot of and that's very true in sorghum. You have a huge range of grain types and how the grain is held, tightly, loose versus no grain at all.
So that actually reminds me of something else, is like when it comes to these questions, your expert knowledge is just as much or more important than the drone technology, being that you got to know the phenology of different plant types to know how, if you can even answer the question you're looking for. There's a number of things that you might run into. But let's do this. Let's move on to the technology. I already see questions coming in the chat about that we'll get to. And this is a good comment. Oh, it was actually someone's Chris had answered about ground truthing. Ground truthing when it comes to this stuff is very important in a lot of cases. Some cases it's not as applicable, but both ground truthing but also training your data if you're doing any kind of classifications, that's important. And when it comes to that, having highly accurately positioned data matters, and that sometimes ups the cost of things, which I didn't include in the equipment section, but we can mention it, that having a RTK or a really accurate GPS unit and ground control targets to position your imagery so you can compare it to ground samples is sometimes important. With that, let's bring up the slides for the equipment, because again, some of the questions I see are going to relate to that. Let me reduce. I see my Zoom here. I want to share again, replace the current sharing, and all right. Good. All right, technology, data products. So what we're going to talk about right now is off-the-shelf equipment. We're not going to talk about like mechatronics, erector set projects. We go to what's off the shelf. We don't need to. We're not engineers like that. We're application kind of people, at least in our group. And so that's what we'll talk about: common uses, or the drones that are commonly used for mapping, and then drones that we're familiar with. So I'd love, Chris, do you want to repeat what you said yesterday about the drones and the importance of them as relative to tractors?
Yeah, I put a comment. I answered that comment in the in the chat or the Q&A, but everyone I talk to, they're like, oh, it must be cool to fly the drone. I'm like, yeah, that's the fun part, but then you got to get to processing all of the imagery and doing the data analysis, which is, it's exciting when you get a good result, but a lot of times it's sort of frustrating doing it as well. So I told Sean yesterday, and people ask about specific drones. I think of the drone more as like a tractor, and then the tractor implement is like the whatever sensor you're going to use for a specific job. So you can, you could use a 1940 tractor and still, disc a field, as long as you have the appropriate disc. Although Sean and I both have the DJI Matrice 100, which is in my garage, and I haven't looked at it in about 5 years. So somebody wants to try it out.
If you can get the batteries to work. So yeah. So it's really, I wish drones lasted as long as a tractor like that. But yes, especially for me coming from a remote sensing background, what you hang off of the drone is a large part of what's important to me. And so that's part of what we'll get into that. But first we'll talk about the kind of the fun things, the actual drones themselves, and we can touch on the sensors. This is one that Ahmad uses quite frequently. Do you want to talk about the Mavic 3 multi-spec, I believe is what you have?
Yeah, so I have here the Mavic 3 multispectral. It costs, as you mentioned, it's 5,000, less than 5,000, and we use it for our agricultural experiments. It has 4 bands, green, red edge, and near infrared with 5 megapixel lens, and it has also a RGB camera with 20 megapixel. It fly for over 40 minutes. This is what they wrote in their website, but actually it fly for around 30 minutes. I used it for over 200 flights now, and it still have the same performance. It's quite reliable, easy to use. I used another one before for multispectral images. I used to set up this drone for more than 20 minutes in the field every time to fly the drone. But for this one, I can fly it in less than 2 minutes. So it was easy to use in field and for the applications.
I might mention this is probably one of my favorite drones.
Okay.
I used to love for a while, we'll get to EBX fixed wing. That was my favorite for a little while. The Matrice 300, definitely I like that a lot. But in terms of convenience and performance and results, it's pretty hard to beat this. It's nice to have something you can carry around in almost a fanny pack. It's a very small drone, but it performs really, really well.
Yeah, it's also, I can add that it has the RTK GPS module, and now I'm not using the base station for it. There is a subscription for a service that you can connect by your phone, and it gives a really high accurate positioning. I tested it several times, and it's within 2 centimeters according to my measurements, and I don't need to have the base station. Just connect it to internet, and subscription, which is $50 per month.
Well, you and I are going to have to talk about that because I haven't used that, and that sounds really nice because the base station is trouble sometimes.
Yeah. Okay.
So just to back up, just so some of you aren't familiar, people aren't born with all the terminology of drone tech. RTK is referring to real-time kinematic correction, which is a very high positionally accurate augmentation of the GPS coordinates of the drone based upon tower data and other things that are around your region to take what be like the 3-meter error that you would have on something like a Garmin or on your smartphone and hone it down to like 5 to 10 centimeters usually. And so, yeah, that's what that's referring to. And oftentimes I use a base station, but yeah, having a service that's piped through your phone to augment the GPS signal, because there's towers that know what are the floating errors of the GPS are. So I'll move on. The Matrice 300, I'll talk about this, but I'll let Chris talk a little bit about the predecessor, the 200. We don't have a slide for that, but that's okay. This is, I mentioned was one of my favorites, still is, because it's really well performing. It's given me no trouble whatsoever. It's a kind of a large drone, can carry over 5 pounds or 2.7 kilograms. That's big enough to carry a LiDAR unit or small LiDAR unit. We'll touch on that here in a moment. But you can put 2 cameras on there, even 2 pretty beefy cameras. Note that everything with a drone is kind of like a trade-off, or it is a trade-off. So if you want to cover, if you want to fly for longer, you need to have less weight on it. If you're flying at higher altitudes, you have to have less weight if you want to fly as long to cover the same amount of area. If you want to cover a larger footprint, you need to fly at a higher altitude, and the legal limit of that is 400 feet above ground level. Some projects call for flying lower to get higher resolution, but everything is a trade-off, I might mention. And when it comes to something like this, one of the trade-offs is that it's just large. The max weight at takeoff is just shy of 20 pounds. They claim a 55-minute flight time, but realistically, you're talking more like 30 minutes when you put on all your instruments. And that's reduced again if you have higher winds, higher temperatures, or really high temperatures, and high altitudes. So you can, it also has an RTK sensor on it. And it's set up with an ADSB receiver that will warn if airplanes or helicopters in your area, which is more important when you're flying around something that's like 30 pounds. It's quite, yeah, that's a large platform to run into a plane. If something like an EB or a Mavic crashed into a plane, yeah, it wouldn't be good, that's for sure, but might not, or likely wouldn't be catastrophic. But something like this could be a lot worse. They say that it has a 15-kilometer transmission range with the Wi-Fi signal to connect to your controller. I bet it does, but there's no scenario where you can fly that far away from you and still have line of sight. It'll disappear at about 1,200 yards, I find. So 3/4 of a mile is the very furthest that you can see it, and that's one of the legal limitations. It has a pretty wide temperature envelope for flying. So from negative 20 Celsius to 50 Celsius, that's really far. The claimed price is $13,000, but roughly. But here's the issue: is that once you actually get the cameras, which might be 6,000, and an Ultim's like 12,000, and then you get a RTK base station, unless you do the service that Ed mentioned, then it all adds up, plus lots of batteries and cases and chargers and so forth. The platform that I fly, the whole package was closer to 45,000. And anything you might mention about the Matrice 200, Chris?
Yeah, it's pretty much the same, except it doesn't have RTK, and the propellers are not upside down.
And it's discontinued, I think, now at this point.
No, I bought the last one available, so yes,
Oh.
it was discontinued after I bought mine.
Oh, okay. So yeah, so this is what you can get. So that's why we don't have a slide for it in here, but it's a good drone too. We have one. That's our backup to this. And you can put similar cameras on them and everything. It's a little bit smaller. Weirdly, this drone is quiet for how big it is. It really is surprisingly quiet. And I think it has something to do with the way the propellers are.
I want to address, Luis put a question: is there going to be a ban on DGA drones because they're made in China? And we had a discussion about this yesterday. I would say, and I've heard several Congress people that are on the Intelligence Committee that was having a briefing today that were, the way they're talking, I wouldn't be surprised at some point moving forward. But they have a lot of misinformation. I mean, they're saying that DJI drones will transmit all of your data directly to the Communist Party in China, and there's no evidence of that. And then what's pushing this is all these people claiming that they're seeing, car-sized drones, which I can almost guarantee you is not some kid playing in his backyard with a car-sized drone. And most of the pictures I've seen, and I think Brandon said the same thing yesterday, they look like airplanes to me. So it'll be interesting to see what comes out of that, but it's sounds like there's a lot of people saying that, you know, New Jersey is being overrun with spy drones in the last week, and so I don't know what's going to happen with that.
So two
Yes.
things, yeah. So Chris mentioned Brandon Stark is the environmental health and safety oversight for all things drone in the UC system. He's also both the drone guru and drone czar for all of the UCs, and a great source of knowledge or information and knowledge if you need it. So we meet with him the second Thursday of each month. There's drone chat that we have that Thursday afternoon, second Thursday of each month. If you're interested, we can get you signed up for that, so you can join us for those kinds of conversations where we cover things like new regulations and that kind of thing, and also just interesting projects and questions in general. So yeah, I would reiterate what Chris just said. There's in my opinion, I'm guessing this is a ton of hype. There's it's kind of, I would say, like a mania to say the drones are bad. And the vast majority of the things that I see, they claim the security risks of Chinese drones are the technology just doesn't do that. It's not as much of an issue as they make it out to be. But there is a push to ban Chinese drones. They've already banned it for federally funded projects throughout the United States. And now, as of, I think, somewhere between the 25th and the 27th of this month, the new Defense Authorization Act will have a section for drones where they're going to do a review of Chinese-made drones. And that period will go for 1 year. And at the end of that year, if they determine that that there's some kind of security risk there, that they will ban them. And it doesn't even necessarily have to be a real serious security risk. It could be, they might just ban them anyways. So that's a possibility on the horizon. And that actually was a great question as a segue into next. What I was going to talk about is the blue list or / US approved drone, US made drones or non-Chinese drones. The number one competitor to DJI, if you could even call it a competitor, is Skydio, probably in the United States. And if it wasn't this, it's probably FreeFly. But Skydio is they make some okay drones. The problem is for the compared to, say, a DJI, this is just my opinion, they are as good as DJIs, but 3 times more expensive for what you get. 2 to 3 times more expensive. I have a couple Skydio S2s. I'm not overly impressed with them, but they work. This one is, you just can get the base model for about $2,000. Here's a little caveat there that their company is very oriented now toward military police and big organizations. And so they don't sell it on the consumer market. You have to purchase it through an organization like, say, the UC. But it's still out there. They don't have any multispectral platforms. They're good at a couple things, and one of which is not running into objects. They have obstacle avoidance that seems to be quite good, and then following functions that are quite good too. So those are a couple things I can definitely give credits to them. And also they have built-in AI, and I'll show you I'm referring to the Skydio S2, which goes for about $2,000, as well as the X10, which I've flown. I don't have one of these. This one's actually fairly impressive, but it's $16,000. It'd be a great drone at $5,000, but at $16,000, it's just a little bit much. And it has thermal capability as well as the RGB, but still no multispectral capability. Great obstacle avoidance, but the AI in it makes it really interested in that you can have it lock onto targets and then follow that target in surveillance mode. It also has the ability to connect to broadband and send signals to like operation centers. I have a friend that's commander in the sheriff's department in Sacramento, and they have some of these that then have real-time data that goes to dispatchers for some operations. So that's what this kind of platforms aim toward, more so than something like agriculture. But we're all hoping that they come up with a more research-oriented drone one of these days.
And let's point out, Sean, so all these other drones, so you're sort of stuck with whatever camera. So with the Matrice 300, the Matrice 200, we can swap out, use different cameras, different sensors. It's able to carry more weight, and they're a little bit more flexible as to what you can attach to them.
I mentioned FreeFly. I don't have a slide for it because I haven't used it and it's very new, but FreeFly Astro, I flew one with Brandon Stark recently, a couple months ago, and I was impressed. And that one you can configure with a bunch of different cameras on it. Problem is you're looking at like $40,000-ish to get a whole package for it, including the cameras. Ballpark of the same price as a Matrice 300, but you're getting up there in cost really quick when it comes to a platform like that.
Hey, Sean.
Yes.
I don't know if you're going to address this, but given the cost of these, is there any rental or borrowing capacity within A&R or also for people outside of A&R?
Borrowing and renting, no, but that's actually one of the topics I wanted to talk about when we get into incorporating this stuff into your research or extension programs.
Okay, great.
I'll circle back to that in a moment. And this is the last of these, and I just mentioned this one because it is not made in China, so it is not counted as on the banned list, but it is a Mavic 3 Pro, but they've sold the rights to this Malaysian company, Anzu Robotics, to then produce them without the Chinese company's connection. The only problem is they don't have a multispectral version of this, and it cost about $1,000 to $2,000 more than the relative or the respective DJI version. I don't know anyone that has one, but again, it's like for the base model is 5,000 instead of 4,000 for a Mavic, and 8,000 instead of 6,000 for a thermal model, and there is no multispectral model. So just but that's out there if you need a non-Chinese drone one. Oh, actually I have one more that I was going to talk about, the EB by SenseFly. This is a great platform. I won't get into it too much because most people won't be using it. It costs a fair bit too when you get all the base station and the ground and so forth that you'll need for it, but talking about 20 to 30,000. And what's really great about this is that it's not the drone itself. The drone is decent, but it's the ability to just launch it and then sit there and let it do its whole mission. Because the flight design software, the autonomous or autopilot software that integrate with it is fantastic. But the problem with the fixed wing is you need a runway or a long grassy or soft area that you can come in and land it on. In a lot of cases in ag areas, you just don't have that. You need to have the vertical takeoff and landing with the quadcopters and so forth. But this is, I wanted to mention this as an option too. Just really, I'm going to gloss over these because I want to make sure we have plenty of time for Q&A, but there's different kinds of cameras you can use. In this case, RGB. You can have single lens refractive lenses that are great. Like the X10P1, they go on the Matrice 300s. And they're great. Some people have poo-bahd RGB as opposed to other kinds of cameras, but they are really good for some things, specifically our photogrammetry and elevation modeling. And this would be a great example of one that goes on the EBX is the SOTA 3D, where the camera swings back and forth as it flies. So it gets not just images straight down at nadir, but oblique angles off to the side. And then when all of that when it gets stitched together through photogrammetry, you get really good elevational modeling or height modeling of your image results. So if structure and height of objects is really important, that's key. Multispectral cameras, MicaSense Red Edge, that's a 5-band, red, green, blue, near infrared and red edge. So the near infrared and red edge are just outside of the visible spectrum and are very sensitive to plant health. And I have a slide on that in a second. And then the Ultim from MicaSense is that with a little bit higher resolution and a thermal camera also attached to it. And one thing nice about that thermal camera is it stitches together in the software at the same time as the multispectral imagery does. And so I find that it's a little bit more reliable than a standalone thermal camera because it can use it can rely partly on the photogrammetry of the other images to help assist the stitching of the thermal imagery. And these run about $10,000 to now up to, there's even more, there's a new version of it that's like 16,000 too. The reason for that, we were mentioning NDVI earlier, and the reason why we use NDVI, if you can see the spectrogram here with the green line and the 2 circles on here, where normally in the visible range, you see blue is low, green is high, red is low. That's why things reflect and look like healthy plants are green. But then the near infrared spikes up maybe 10 times higher than the visible range. And the difference between the red in the near infrared specifically, that's used for NDVI for the calculation. And that gives you a good proxy measurement of the vitality and health of plants. And that's why we use multispectral. And then so those multispectrals just connect to those specific sections of the electromagnetic spectrum. I'll mention thermal. This is mostly used for water type characteristics or features in a landscape because that's what's most sensitive to, being that water's hotter, colder than the surrounding areas. And so that's what that's used for, unless you're using it for search and rescue or something to that effect. And I'm going to mention the hyperspectral sensors, even though I doubt any of us will be using it, but it's something that might come up. The difference between a hyperspectral and a multispectral imager is that something like a Ultim might have 5 spectral bands, red, green, blue, near infrared, red edge, where this will slice up the electromagnetic spectrum sometimes into a range of like 400 to, or like hundreds of slices of that electromagnetic range. And the thing with that is it adds tons of data. It's very cumbersome to work with, and it's kind of an overkill for most things, and is very expensive and difficult to process. So I just wanted to mention it though. Along with LiDAR, which we don't have as well, but I've worked with LiDAR data. That's light detection and ranging in this case, on a Trinity F90, who Becca Fenwick, who we work with sometimes, has crashed theirs with a LiDAR unit on it recently. So with a fixed wing and an expensive LiDAR unit, the whole system was, I think theirs was closer to 90,000 instead of 50,000 when everything put together. But insurance is covering it, but that's an issue. But light detection ranging is great for instantaneous, highly accurate position of elevation. You can get a lot of that out of photogrammetry that I mentioned before, but in a lot of cases you need clean penetration all the way down to the ground, and it's better in a lot of ways. I'd be remiss if I didn't mention software applications too, which you can, if you need any help with that, reach out to IGIS. We have Pix4D Mapper. We have ArcGIS Pro licenses for all of us. And if not that, we also have Drone to Map for RGB. And that's super easy to use. If you're just using RGB drones, we can get you set up with that, no problem. And then some of the products that we get out of that are orthomosaics, vegetation indices. That's like the NDVI that I mentioned, with mathematical differences between red and near infrared. Point clouds, digital surface models, and textured meshes, which won't come up in most of our research. And with that, let's see. I had more here. Just a second. I'm going to look because we had some more. I want to see how many slides we have. Oh, this is just the one slide. Pix4D fields. I assume.
Yeah, it's just another software, easy to use, user friendly. built for growers mainly, and it has quite simple tools. It can do the image stitching, and you can use AI tools like you divide your field to grids, and for each cell you can decide which one wanted or unwanted. They call it like this. So it's an AI model that selects the cell you need, and it's quite useful tool, especially for weed detection. For example, this is an example for weed detection.
Great. Yeah, so this is a lighter weight version of Pix40 Mapper that I mentioned before that we have like 25 licenses for in IGIS, mostly for educational purposes and research, but Pix40 Fields is more of an on-demand, like a almost real-time or near real-time result. You can get out much faster processing, but not quite as scientifically robust in some cases.
Yeah.
Yeah, so
And I use both. I mean, actually the Pix4D mapper, I don't think they're making any improvements to it anymore. I think it's sort of where it is, and
I have the same experience.
yeah, any work they're doing, they're putting into Pix4D fields.
that's good. It's good to know. So with that, let's see, do we have questions? I'm gonna go bring up the chat. Let's see here. I see that some of you have been, so does ANR allow for DGI? So there's we're not the ones restricting it. I like DGI a lot. I think I'd call it propaganda. The concerns about it rather are extremely overblown in my opinion. There's
No, but we're talking about purchasing. So apparently we never finished that conversation with Brandon, but it sounds like Davis has purchasing must be preventing people from buying DJI drones on campus.
It hasn't come up recently, but if you are an ANR and someone wants to place a purchase, I'm the drone safety administrator for ANR. So I'll usually get a phone call or an email saying, is it okay if this person purchases that? And I'll almost always know the person and know what they're doing. I'll be like, yes, like I haven't had to say no yet. There's and the only reason I would say no is if there was some legal concern or safety concern that
well, and EH&S always I have to answer specific questions that you understand what the regulations are and what the university policies are related before they'll approve your purchase.
So when it comes to strictly to the law, if it's being purchased with federal funding, no, you can't purchase them. If it's state funding or some other type, essentially state funding or other source, endowment say, then legally speaking, yes, you can. The problem is that there might be a chance that the drones are later banned, but I don't see that necessarily for drones that are already owned. You just can't then use them on federally funded projects. Good.
You can't pay for them with federal funds.
No.
I use mine on federally funded projects all the time, but.
So if you already have one, you can use it for federally funded projects. And there's weird loopholes that I don't know. I don't think.
Well, don't tell anyone because the USDA paid for my last one.
No, I'm not.
I didn't ask any questions. So.
Yeah. So you can have the drones, and really here's one of the loopholes of why I say you get a Chinese drone, but you're collecting the data with an Altum, and that's not a Chinese, doesn't have anything, the data that you're collecting is not Chinesely, like it's not accessible to the Chinese government in any way, shape, or form.
And you're processing it with a Swiss software.
Yes, exactly. So there's so many loops that make it kind of like, I don't know, they said not valid in my case as a concern, but still there's but technically speaking, I think you got one more year if you already own a Chinese drone that you can use it on federal funded projects. If you're like, for example, I'm on an NSF grant that I fly for, but this next year's the last year of the project because we can't use the drones into the next year.
So I haven't heard that you can't use them on a project. So the federal government's going to buy everybody new drones that are, that are not DJI.
Right. There is a weird loophole that I've heard of people using, but they are contracting out to someone else to do a project, and it's like a no ask, no tell sort of what drone they put, say, their Altum camera on to get the data. But yeah, I don't know. We need like a little bit more clarity on that. And that's a question I should revisit with Brandon Stark. Good.
But I think as far as questions, I mean, I think I think you sort of got an overview of what things you can do, or if you have other ideas, you can join Sean and them on their office hours or monthly drone chat, which is usually 4 or 5 of us. So it would be great to have some more people. And you know, you really need to think through what you're going to do. You know, Sean and them helped me out quite a bit. A lot of it I've learned myself through trial and error. Some things I would do a little bit differently. So it's just, you know, if you are gonna spend money, and like there are options now, like you know, at least for now, the DJI, you know, ag multispectral, that in a lot of cases would probably work just as fine for most uses as what my, you know, $13,000 Altum camera does. It doesn't have the blue band, but you know, for NDVI or you know, depending on what you're using it for, then it may or may not be that critical.
Yeah, referring to the Mavic 3 multi-spec.
And you know, other things though too is I mean, we talked about the money. The other thing is it's a big time. I mean, it is a big time investment. So if it's something you're thinking you would use once a year or something, it may be better to try to work out, you know, some funding in your grant to hire Sean or somebody. There's a lot of independent people that are setting up businesses now. Have to probably determine whether they can do what you need them to do. But in some cases, it may not be worth the time if you only need a couple of flights a year or something like that versus I probably this last year I've flown from I think the number of miles I've flown, I could have gone from San Luis Obispo to Davis and back this year.
Yeah, I'm sure.
But
oh, go ahead.
Luis asked about pesticide and fertilizer applications. Now there's a whole bunch of different regulations around that. So if you're, you know, from a FAA standpoint, that's considered, you have to follow all of the rules that are apply to crop dusters, manned aircraft. And so you got to go through and get exceptions to certain rules, like the rule that you have to wear a helmet when you're flying, and the rule that you have to wear a harness when you're flying. And then DPR apparently has been forced to lighten up on their rules a little bit, but you still have to work under somebody that's a journeyman as an apprentice for 50 hours before you can be licensed to apply things. So if you're using a pesticide, it's considered a hazardous material according to the FAA.
Yeah, you got a couple things going on there, and this also relates to Denise's. Dennis's question is about the Agra series is a pesticide applicating drone from DJI. I've flown that a couple times, but the challenge there, especially in California, some states are more lenient on this than others, but the Department of Pest Regulations says that you need to have a aerial pest applicator license that Chris was mentioned with the 50 hours of flight time under a journeyman, which is a lot of time to fly drone that only flies like 10, 12 minutes with a load of pesticide on it. That's so many flights. It's kind of prohibitive. The most people that I've heard of that do this, they got their aerial pest applicator license in an occupied aircraft, and then they went and got the, well, I think it's the Part 136 on for heavy aircraft, heavy drones. To
37.
What's that, 37? That's it. Yeah, 137 to be able to fly with the heavy platform. And so that's the way more feasible way, because trying to do that with a drone, just get the aerial pest applicator license with someone overseeing you flying a drone, it's just, you just can't get in enough hours that way feasibly.
And let's just say, in my opinion, I got a lot of pressure from some of the statewide Farm Bureau and a couple of legislators at Sacramento wanting me to do pesticide trials with drones. And, you know, when I looked into it a year and a half ago or 2 years ago, and I'm like, I can't do this unless that's all I'm gonna do. I'd probably need, you know, I told them I'm gonna need $200,000 just to get set up. You need a whole trailer to haul all of the equipment you need. And then the 50 hours, I would probably have to hire a person that actually flies an airplane, whether they know anything about flying a drone or not, to supervise me for 50 hours, which would not be very cheap.
Yeah. So with
I
that
have
said,
a question. I don't know if you can address this in the few minutes left, Sean. I know you have this other section. I'm interested in a scenario where somebody isn't doing like very like statistically rigorous and detailed research, but more like simple demonstration trials. And is there value? My question is there value, or is it worth it to use drone imagery as more purely an educational or extension tool? Like, have you had any experiences, those of you who have used it, where you see people have sort of an aha moment when they see this imagery? And Chris, you kind of started talking about that earlier a little bit with the fungicide, was it, application?
Yeah, and I mean, I have pictures of our, you know, celery. I'll use RGB images of our like celery trials for disease resistance. And I mean, you can tell the difference, the ones that are susceptible are only, you know, 6 inches tall versus the, you know, 3 feet tall, you know, and you can see the yellowing and stuff. So, I mean, yeah, it makes it makes some nice pictures and visually being able to see things next to each other. And then I know there were some questions. I don't know if Jeff Mitchell's on here. I know he was asking about cinematography, you know, so videos are always a good way to tell stories and stuff. And I think for some of those things you can do, you know, there's a lot of options that you don't have to buy a $10,000 sensor.
absolutely.
You could probably, if you wanted to do fancy videos, you can probably buy a $30,000 video camera, I'm sure, to put on a drone, but I'm not sure that it would be worth it.
Now, by just a side note, for cinematography, the Skydio platforms are pretty good for that because of their following option is really neat. But yeah, to what you're saying, yeah, Sonia, that we can touch on that a little bit here in referring to the education programs. I'm a co-PI on a fairly well-funded project with 4-H to develop a curriculum for high school aged students that's focusing all on the RGB style drones, but streamlining the data, processing the regulations, all of that into a clean, nice package. That's but a lot of what the formulation of the information that comes together in that comes from learning the hard way and all these other different like different types of projects that are more scientifically rigorous. And so, yeah, and it doesn't matter what kind of drone, what kind of imagery you need, whether it be video or photogrammetry or just photo points. drone 360. So those are all different things, but just to kind of finish up. So yeah, there are considerations. I said I'd kind of loop back to this and from one of your questions earlier. What are your project goals, your budget, how much time do you have, your available options? And like Chris mentioned, there's it might be cheaper for you to contract to someone else to do that, because to purchase all the equipment, get up to speed with the regulations, to actually go fly, the processing time, it can be enormous, the analysis time can be enormous. And with that noted, then here's an example that we put together some time ago. Andy and I, mostly Andy Lyons, that is. So we took 3 projects over time, and when we looked at where the time was spent, you can see that there's mission planning, the prepping the gear, the loading, and we're not even counting the like all the meetings that lead up to it to know what the scientific question is, and then the purchasing and that sort of thing, and registration of your drones, but then loading the gear, the drive time to the sites, ground control point placement. The flights only added up to 7% of the time. And then you have the data management and processing and the GIS and the data delivery. And that doesn't even mention the storage and visualization kind of stuff that comes on the end as well. So all of that can add up to 50% of a project into itself. So that's one of, and I highlight this just because it does matter if you think, well, maybe we'll do it in-house. If you have a project that you're going to continually go out like Ahmed is and doing, amazing work. I mean, fantastic work up there in Intermountain Rec. That makes a lot of sense to have someone like him there that does all that. But if you're just going to do a project here and there and now and then, and you might want to reach out to say us. And if we don't have the capacity, which sometimes we don't because there's a lot going on, we can sometimes help out giving you options. Good. And let's see. And with
I may
that,
add something here also. Last year, I was searching for a company who offers this kind of services in our area, and I found a company in Reading. It's not a company, it's just one person who has a website, and he offered drone flights, and it was around $300 per flight. So he can fly whatever you want and give you image. So if you want to have this number.
And there's people, I mean, there's people all over Southern California and through the Central Valley too. I've been getting lately about 1 call a week of somebody wanting to set up a company. What I haven't gotten to is I try to ask them what they're going to do, and they're like, well, I can do anything. And I'm like, how much are you going to charge to do this? And they're like, we don't know yet. And I'm like, you're going to have to figure out how much it costs you, because if you know, a grower can do it more cheaply some other way or himself, it's not going to pay for your service. So
yeah, and also will not pay for the data analysis.
yeah,
referring back to that, so you can see on this chart here the map, the GIS and analysis. Last 2 steps are a significant part on top of that. And I've found almost no one that does the full spectrum of what you need to do, like everything from the logistic, the planning, the flights. That's the part they usually advertise, but then the processing and management, and then an analysis and creating a usable product, that's a little bit harder. Usually when I go out on a project, I'm just thinking back, it's usually about $450 to $1,000 a day of flying, because then there's processing and a little bit of GIS on the end of it and packaging, delivering. But that's ballpark of just of a day's worth of work. Depends on how long of a day, but yeah, and it's also the logistics of getting to and from somewhere. I say 450. That was like the project that was with Daniele, about 15 minutes from the office, that I could go out there, do it, come back, and then process it in the same day. Most projects are like going down to Fresno and then back, and the drive time, it all adds up. And last things I might mention, and then we'll call it quits, is this the pipeline and data management. You create tons of data with this, and you have tons of products. So don't forget that. That's the one thing I wish I would have known when I started, was how to manage the data better. Takes a lot of trial and error, and storage, and cloud storage is an option, but there's keeping that sorted out is good. And with that, I think that we are 2 minutes over now. And so I think we can we can stop here. We can take a couple more questions for a few minutes. But for the rest of you, thank you for coming to this webinar. Feel free to sign up for the IGIS office hours on the UCANR IGIS website, and you can look at our training calendar there. And if any of you are interested, we do drone camp the last week of June each year. In fact, Ahmed and Chris, I think that's where they started off at, and now are instructors there and are a couple of the best experts in the UC system for this kind of stuff. So that's an option if you really want to get a lot more hands-on information.
Yeah, and if you come to that, you'll usually get to see one of the instructors crash a drone. So
I haven't crashed one there yet, but we had someone really good crash one though once. Good crash, but that.
Please
But thank you.
also
And
fill out the brief evaluation survey I just put in the chat, and we'll send that by email as well. But thank you, Sean, Chris, and Ahmed. Really appreciate it.
yes, the evaluation will go out. Please fill that out. It matters a lot to us. And thank you very much, and have a wonderful weekend.
Thank you.
I'll stop recording now.
there's still messages coming on, or thank you.
Great.